Assignment 7 was the assignment for the day, but now it's not anymore. The Wilson Project student. All right, today we're going to step backwards for just a second and take a look at Polygon programming, and specifically Polygon collision detection. Polygon's great. Next class period, I'm probably going to make you do a Polygon thing that uses a polygon within the context of an object that you write. Right? Gave you an object that was a Wilson. You played around with it, you made it work, but you have a lot more to assimilate about objects if you're one of my new programs. So it'll really be something that you can work with yourself. And the reason I'm spending so much time with objects is, one, if you understand object-oriented programming, you can be a programmer. Simple as that. You could do it. So for all of you who are about to take off to college, if this is an interesting skill set to you, congratulations, you're going to have it before you leave. But more immediately, the AP CSP test will require you to write for the Create project your own program, right? And submit and upload to them. As part of that, you're going to have to analyze your code for a concept called abstraction, which we talked about a little bit last class period. I did, right? So object-oriented programming is a really good way of implementing and displaying abstraction. Abstraction covers a lot of ground. It's hard to succinctly is. But one of the parts of abstraction that we look at is the concept that we don't need to pay attention to all details in order to get stuff to work. For instance, our car engines. We assume that when we press down on the gas pedal, they're giving the car more gas. You would agree with this? Okay. How many of you have heard this story before? We're not giving it more gas. What you're actually giving it is more air. It's also called a throttle because when your accelerator is lifted, there's a valve in there that restricts the amount of air that goes into your car. When you press down on it, it opens up that throttle and you're able to accelerate. So we don't really know very much about our cars. They're black boxes. We interact with this, the stick shift, the turn signal, not as often with the turn signal as I would hope, but you know, and the pedals on the floor. That's it. But we don't know how they work, and that's an implementation of abstraction. We don't know. We don't have to know about the fuel mixture, the quantity, the proportion of gasoline to air that goes into your engine. If it's not perfect, it runs like crap, which is why back in the old days, cars at high elevations would stop running well. If you're going over the Rockies, it was a little rough in your Model T. You had to get out and fix the ratio of gas to air. So they're black boxes to us. They use abstraction in that we don't need to know. We just push this thing on the right and we go faster. Make sense? So that's an implementation of abstraction. Objects are the same kind of way. We don't care how collision detection works between polygons. We just want it to work. We don't care about matching this pixel against that pixel or that hypothetical space against the other hypothetical space. We don't care about this. We just want it to work. So we use things that have already been written in the language or things that we, for a program, to not care about them, just make it work. Does that concept make sense to you? About way, but whatever, it's all relevant. Okay, so what we're doing with this is I'm having you create a game-like program. It does not emphasize graphics. Repeat after me.
It does not emphasize graphics.
Thank you. Repeat after her.
It does not emphasize
Very
graphics.
good. See, she's the first one of anybody in this class to finish AP Computer Science A. So I taught you well. Which means your skills are everybody else's. That's really what that means. All right, so it's not about graphics. I just want things to appear on screen. I want polygons to appear on screen. Are you with me? Good. I want polygons to appear on screen. I need 2 polygons, and I need the polygons to be controlled with key listeners. Because as it turns out, I did not yet teach you the mouse motion listener. So you're not responsible for that. Key listeners, drive your polygons around the screen. Make sense? Okay, so you were using key events to drive your images for your car game. This is the same kind of thing. Your key events change things and move your polygons left and right across your screen. Drive them around your screen. The idea here is that your polygons, if they overlap, if they intersect, should make something happen. So I'm checking you for the use of polygons and collision detection. So let's examine that a little bit. You'll notice I have a bit of sample code here. You're welcome to look at that again. But here's how the collision detection thing works. Okay, so when you were doing your car exercises, right, you had a rectangle for this and a rectangle for that. And if our rectangle 1 dot intersects R2. Nodding of heads, comprehension, are we good? Great, 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 great. And this is the results of all that. Collision detection with polygons works the same way. It's just it takes one extra step because a polygon doesn't intersect with another polygon. It doesn't have that level of abstraction written into the language. So what we have to do is get a bounding rectangle for the polygon. So we say if polygon 1 dot get bounds, parentheses. It's badly written, you can't read it. Dot get bounds. And that gets the bounding rectangle out of a polygon that you've drawn on screen. Getting that in a second. But this evolves. So here we're talking about a polygon. By the time we get here, we're talking about a rectangle from the polygon. Does that make sense?
It draws it for you pretty much. You don't have to, you don't have to set the rectangle.
Right. It just generates one on the fly. Kind of cool.
That would have been so helpful 2 years ago.
What's that?
That would have been so helpful 2 years ago.
You know, I tell people every year, I keep changing my class, I keep adding new stuff, you know, and I'm sorry, you took my class too soon. Actually, you didn't, but...
Should have taken AP Stats.
What's that?
Should have taken AP Stats.
Yeah.
That was like the most stressful week of my life, choosing between.
Dot intersects polygon 2 dot get bounds. Parenthesis, 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 and we're done. So this becomes a rectangle. This goes from being a polygon to being another rectangle. You make a rectangle dot intersect a rectangle, and it doesn't give you another rectangle. It gives you true or false. That make sense? So it evolves as you go your way through it. Yes, ma'am.
So if you have a triangle, it would actually, the intersection bounds would be within an imaginary rectangle surrounding
Yes.
it? Okay.
Brilliant. Somebody did a really cute little polygon in one of the exercises I graded yesterday. Their polygon looked like this, a little spaceship looking thing, right? And it was cute. It drove around the screen well and everything. I liked it. And it just stuck in mind. I forget who did it. But as a collision detection device, it will have certain shortcomings because the bounding rectangle really looks like that. I know that's a terrible rectangle. Work with me, people. I have my limitations. So that's a bounding rectangle for that. Now, if we were to have a second polygon on screen, let's say Miss Smirnova's, even though the green and the red do not intersect, their bounding rectangles, different color, their bounding rectangles do. Right? So we have these giant dead spaces around our polygon. And I'm willing to work with that for the time being. You know, it'll appear to collide when in fact, visually, they're not colliding. I'm willing to being because polygons themselves are not the final product. They are part of a composite product when you're really trying to do graphics well. And that's how you make it work. That make sense to everyone? Questions about this project I'm looking for? No questions? Awesomeness. It's great. Big picture stuff, small pictures. Beginning of next class. Remember, this is not a work of graphic beauty. This is work of mechanical excellence. That's what it
We just need polygons.
was. Mechanical excellence. How often have I? No. Obviously, you have to get snarky. I'm sorry, Luke. I'm not gonna do it. Yes, sir. What's up?
We need like to end the program if it's much or something like that.
Do what now?
Is the program like ended?
Sure. Yeah. If they intersect, maybe they both change colors. Maybe the whole computer program shuts down. Maybe they bounce to opposite corners. Maybe they move out and get faster. Whatever you want to do, go have a little fun with it. It's not a game per se, but it is things interacting. Are we cool? Dan.
Does this need to be its own Polygon class? Like, do we need to rewrite a Polygon class, or is it just like, just throw it
It's
in
not
the
even
driver?
object oriented.
Okay.
Yeah. Just include polygons in the driver and you're good. Oh, one more thing. For my new programmers, make a brand new project. Some people have been just adding class project that they can keep track of, and I'm getting like 27 different Java drivers in there, and I don't know which one's which one. That's kind of a rookie mistake, and I haven't really guided you against doing that. But go ahead and make a brand new project and begin that way. Make sense? All right, Mark, set, go, yo. You're awesome.